Today kicks off a brand new series on this channel. In this video, you're going to watch a full project from our AWS Bootcamp, exactly as it's implemented inside our platform. No simulations, no demos. This is a real project just like the ones our students build inside the Cloud Bootcamp. In this project, we'll perform a complete on-premises to AWS migration, creating a VPC with public and private subnets, setting up an EC2 instance, an RDS MySQL database, and finishing with an internet gateway to make the app publicly available. This is one of 40 plus hands-on projects based on real-world enterprise scenarios included in our bootcamp. And one quick note, on November 24th at 8 p.m. Eastern Time, I'll reveal the last ever opportunity to get lifetime access to all bootcamps. Then if you miss it, you'll never have this chance again. Now let's dive in and watch the full project in action.
Hey Bootcamper, welcome to your second hands-on project. I'm very excited to be here and I hope you are too. If you remember the last time we worked on a hands-on project, what we did was that we worked on the migration of user account from on-prem servers to AWS IAM service. And this project is actually very similar to that, or you can say this is going to be in continuation to the last project that we worked on. So today we will migrate a workload that is running in an enterprise data center, and we want to migrate it to AWS. Our mission will be to migrate an application server to AWS EC2 instance and a database that is like running on-prem. So we want to migrate that to AWS RDS service. Now we'll be doing all of this within our own VPC, which is a virtual private cloud, or you can say that it will be our own virtualized network on AWS. At first glance, it seems like a simple thing, right? Let me tell you, one of the most important things that you will learn in your cloud journey is that you should never ever underestimate a cloud migration project. We should plan everything out so we don't miss anything. And what happens is that if you don't plan these projects properly, these migrations can turn out to be a nightmare really. A lot of things can go wrong, which is why we should always ensure that we have a proper plan in place for these migrations. So this is the reason that as part of this bootcamp, we're not only covering the technical migration, but we will also be spending some time in planning this project out. So you can learn how you can plan and tackle your future cloud migration projects. Let me quickly move to the next slide where we will see the steps that I follow while working on a cloud migration project. You can also follow these steps when you're working on your cloud migration projects with big organizations or small organizations. So whatever is the size of the organization, these steps you can follow to ensure that you get consistent results. So first up, we have the planning phase. Now this is the most important thing in this entire cloud migration project, because everything you do afterwards actually depends on the plan that you have made. So while planning, the first thing that we want to do is that we want to work on the sizing. So sizing basically means that what are the specifications of the resources that are running on-prem, and what should be the equivalent for AWS cloud. So this way you can do a mapping from an on-premises host to an AWS instance. In our case, we will be looking at the resources our server is having, for example, the CPU, the memory, the storage, and then we will be determining the instance type on AWS so we can match the on-prem specs. Or if possible, we can even have better specs than what we have on premises. So that is the sizing exercise that you need to perform for every single resource that you want to migrate to AWS cloud, whether it is a server or a database or whatever component, you need to perform this activity. So if you see here, we have on premises, we have 1 CPU, 1 gigabyte of memory, and then 4 gigs of storage. And similarly, so what we came up with was that we identified that, okay, on AWS, there is a T2 micro instance that actually matches what we have on-prem. So we have 1 CPU, 1 gigabyte of memory, and then 8 gigs of storage in this EC2 instance. And similarly, if you talk about the RDS instance, then we went with the T3 micro. So what happens here is that there are 2 CPU, 1 gigabyte of memory, and then 20 gigs of storage. Now this is important because we'll be storing a lot of data. So the more the merrier, the storage. So that is a good thing. So next up, we also need to work on the prerequisites. Now the prerequisites are the dependencies that you need to ensure that you have set up to ensure that your services run smoothly. For example, like you saw in the architecture diagram, you need to migrate a database. So you might want to plan all the software dependencies. For example, if you're running a database version ABC, let's say, and now to migrate to AWS Cloud, you need to check that if the same ABC version will work smoothly on AWS, or you need to upgrade. Other thing that include in this phase, the libraries that you'll be needing to work for your application, the operating system that your application will be needing to run. So if I can go next, so you can see here, we'll be needing the Ubuntu operating system for our application, and then some packages, some libraries or tools that we need. So we need Python 3, and then we need Flask library. So a lot of things that are needed here, and we'll be identifying all of these things in this step. So all of these things, they actually come under the prerequisite phase. I'll also be sharing a spreadsheet with you that actually I use during the planning phase. So you can also use it and can plan your projects better. But for now, I just want you to try to understand the concept of this process as good as you can. So once you're like having a good grasp on this planning and this entire migration process, then you'll be ready to work on any sort of migration process. So after the planning phase, we have the running phase, or you can call it the execution phase as well. So in this phase, what we do is that we work on the actual deployment. So all of the stuff that we have to do on the AWS Management Console, will be provisioning resources. And while doing that, while like deploying the actual stuff, we also want to ensure that we follow the best practices. For example, a best practice is that we should never expose our database to the internet, because what you're doing is that you're exposing your data to the internet, and bad actors can perform some brute force attack, and all of the data that you have, it can be compromised. So it is one of the best practices that you don't expose your data to the internet. If you want to learn more about the best practices, I will highly recommend going through the AWS well-architected framework that has a lot of best practices we can validate over there. You can go through that and understand what you should do and what you should not do. Now during execution phase, you also need to be sure that what technologies you need to use, right? So for example, if you're not aware about the EC2 instance type you're going to use, how are you actually going to deploy it? Because you're not aware that what do you need to do. And if you're not aware what you need to provision, there is a possibility that you provision the wrong instance type, and later on your applications are not running, and the project that you're working on, that is unsuccessful. So we don't want that, so which is why we spend as much time as possible in the planning phase. So we have everything written down, we have everything noted, and then we went ahead or go ahead with the actual deployment. Once you're done with the running phase, with the execution phase, now we have the go live activity. So go live activity is where you actually start using the AWS cloud environment. And you just switch the key on your local on-prem environment, so you don't use that anymore, and then you start using the AWS environment. What happens is that in this phase, first of all, what we do is that we do a quick validation that everything is working fine. So you can say this is a simulation of the actual migration. You just see, or you can say you just dry run that if everything is working fine, and if yes, then you actually start your discussions with the business teams that okay, everything is fine, we are ready for the actual go live activity. And once they give you the go ahead, after obviously some negotiations, because in some cases some organizations, they might want to perform this go live activity over a weekend, because you will be having some sort of a downtime. You'll be turning your applications off on on-prem servers, and then you'll be gradually starting your applications on AWS. So there is some sort of a window where your applications will be down, and you need to discuss all of these things with your business teams first to first of all like decide which day you're going to perform these activity. It is possible that the business team, they tell you that, okay, we want to do that in the night time on Sunday, because that is the time where mostly people are not really using their applications. So it is possible, just discuss that with the team and have that meeting. So that is important. And all of these things, like once you're done, once you're ready, once you've identified everything, and then you perform the actual migration. So there is a cutover period. That is the period where your applications are down. So just discuss all of these things as well. Lastly, we have the post go live phase. Now, this is the phase where your applications and workloads, they are running in production on AWS, and now you're just monitoring them and seeing that if there is any issue with the stability of the applications, or if there is anything that is wrong, so you can quickly identify and fix that. And also there is an ongoing support that your team will be providing to the company that you have just migrated to AWS, and this support will be including any issues that the company faces, and you will be there, your team will be there to help with that. So with that, the migration process actually ends, and you have once you are done with this process, you have successfully completed your migration. And now what we're going to do is that we're going to go through these steps one by one in the next videos. So the next video will be all about planning. So we'll be planning this migration that we have the project that we just saw earlier, the AWS architecture. So what we're going to do is that we're going to be working on the planning part. We'll be working on the sizing and the prereq, and then later on we'll be working on the actual deployments. The thing is that staying organized is really important when you're working on a cloud migration project. So whenever I get such a project, I always ensure that I keep things organized in a spreadsheet, or sometimes I even use Microsoft Project for this purpose. You can use any tool, but at the end of the day, you want to ensure that everything is organized at your end, so there are no surprises later on. For the planning piece, let me quickly open the spreadsheet that I use for cloud migration projects. Normally what happens is that on such projects, the companies that you're working with, they only share a few host names or some IP addresses with you, and nothing else really. So it's important that you manage your own documentation. You can also find this spreadsheet below this video in the attachments if you want to use it for your projects as well. So in this spreadsheet, we have two views side by side. One shows the on-prem resources, and the other one shows the AWS equivalent of those resources. So you put here anything that you want to migrate to AWS, and this will also work as a baseline for you to you come back and see what you need to do during the execution phase. So if you see here, we have the server name that is in most cases that is provided by the company that you will be working with, and then there is an IP address associated with that server. So this will also be provided. So mostly in most cases, these two columns are the only information that is actually provided to you. And if you're lucky, in some cases they also provide the description. But again, these things you have to actually ask these questions, find these answers, and put them down over here in this document, because this will be really helpful when you're actually working on the execution. Also, in this sheet, you'll actually be putting anything and everything that you want to migrate. So in our case, we are just seeing two rows over here. So we just want to, if you remember the use case that you're working on, the project that we're working on. So we just have one application server that we want to migrate, and then there is a database server that we want to migrate as well. Then we have the specifications. So if you see here, we have the total RAM that is available on-prem, and then the total vCPU, the total storage. This is something that you have to actually come up with. All these numbers, you have to actually find all this information and fill it in, so that it is easier for you to identify the equivalent for that. This is also the part that we are actually mostly interested in, because this will be something that we'll be using when we're looking for equivalent or something even better on Amazon AWS. And again, in our case, we just have 2 entries over here. The thing is that the process that we'll be following, it will be the same. So even if you have 2 resources over here or 200 resources, the process that we're following, it will be the same. You have to do the same thing over there as well. Now, if I come to the right hand side, we have this is where we actually add the AWS resources. There are some instance name that you actually have to give. I'll come to this later. And then we have the service what sort of a service that we'll be using over here. So for the application server, we are using Amazon EC2 instance. That is the service, EC2 service. And then for DB server, we'll be using the RDS service that is provided by Amazon. Then we have the instance type over here, the instance size, sorry. So what is this instance size is that what sort of a instance you want that fulfills all these specs. So we have gone with the T2 micro that actually fulfills these needs that we have. Then also another important thing is that you have to specify the region and the availability zone. So if I share a personal experience, what happened with us was that during a project when we were working on the cloud migration, we completed the process, and then the application servers were deployed, and then we figured and we found that we actually deployed our things in the wrong region, and it was not required. So we had to do the the deployment again, and then we had to do the migration again. So this was this was all very hectic, and in order to avoid that, you have to ensure that you fill in these details over here at any cost during the planning process. Also we have the availability zone, and then you also specify what VPC you're going to be using. So this is again the name of your VPC that you'll be creating, and then the subnet you also provide over here. So now let's talk about the naming convention that I use in the instance name column. So this is something that I would recommend that you use as well, because this will be really helpful when you're working with a large number of resources that you want to migrate. So first of all, we start with AWS, that is the cloud service provider. So you have to give in the first 3 letters as the cloud service provider. So in this case, we're working with AWS. So if you're working with, let's say, Google Cloud, so you can type in GCP for that. So you'll be able to identify that, okay, what's happening here. And then we have the region where this service is going to be deployed. This server is going to be deployed. So for our case, we have US East 1. So I have typed US E1 over here, and then we call it the since we are deploying the application server, so I've said that this is going to be app 01. And similarly, if I come here, so we have AWS US East 1 and then database 01. So this is how I actually use the naming convention. So let's say that if you have around 100 resources written down over here, and this will be very easy for you to identify that, okay, what is deployed where, and what service is that, and what is the cloud provider. So everything will be crystal clear with that. So with that actually sums up the sizing process that we follow. And then next up we have the prerequisites. So again, these are important to list down, so we are aware what are the different dependencies that we need to add to our application, so that our applications are actually running smoothly. So if you see here, we have the host name over here. This will be the database that we have, and then we're specifying that, okay, what type of a prereq this is. So we have the software prerequisite, that is the MySQL one. So we need MySQL in our database host. So that is a very understood thing, and I think that is the most important thing. Without this, you can't really run the database if you don't have MySQL installed. And then we have also specified the storage that will be requiring. So 4 gigabytes of storage. That is, again, this is just for our project, and for a real project that you'll be working on, the number could be really high, and the number of prerequisites could also be very, very, the list could be much bigger than this. And then so these were the 2 database hosts, and then I talk about the application server that we have. So Ubuntu is going to be the operating system that we have figured and written over here. Then we also need the Python 3.5 or higher installed in the application server. After that, we have some packages that we want. We'll be needing some packages for Python to run smoothly. Then we're also specifying some Python libraries that what we're going to use. Also, another thing that I actually do was that I list down the commands to actually provision these or install these prerequisites. So if you see here, we don't have any command to actually install MySQL. So I have written not applicable over here, but for the prerequisites, we have actually command. So I have written the exact command. So we can use sudo apt-get install python 3 to install Python 3. And similarly, we can use all these commands to install all these prerequisites. With that, we are actually done with the planning. Now again, I would like to emphasize the importance of this phase, and that you should spend some time here, because if this isn't done right, then you will encounter numerous problems later on.
Hey, quick break before we continue. Have you signed up for the Lifetime Access Black Friday live event on November 24th at 8 p.m. Eastern Time? This will be the last time ever that we'll offer lifetime access to all boot camps, cloud, DevOps, artificial intelligence, and bonuses revealed only live. You'll get 40 plus real-world projects based on enterprise scenarios. Click the link in the description or scan the QR code to secure your spot. After this, there will never be another chance like it. All right? Now let's get back to the video.
We're going to get into the AWS Management Console, and we're going to provision some resources. Let's just quickly look at the different migration stages to see what we have completed so far and what we'll be working on today. So we have already completed the planning phase, and now is the time to start the running phase. We'll be working on deploying the resources. We'll be provisioning a VPC, then we will provision an EC2 instance, and then we'll go on to provision an RDS database. We have a lot to do, so let's get into the AWS Management Console. So here I am in the AWS Management Console, and let me also pull up the spreadsheet that we were working on in the planning phase. We'll be creating these resources, and we'll also be using the same naming convention that we have over here. You can download this spreadsheet right below this video if you're following along. Also, you can find the technical documentation as well, and that will be really helpful when you're doing things by yourself. So let me go back to the management console, and the first thing that we want to do is that we want to create a VPC. So I'm going to type VPC in the search bar. I'm going to do that, and it will take me to the VPC dashboard. And over here in this dashboard, you can see a lot of things. What we're interested in is this create VPC button, because we are going to create a new VPC. So if I come here, you can see that there are a couple of options. We have the VPC only. That is not selected by default. We have another option that is VPC and more, that is selected by default. And what happens here is that whenever you do this, so multiple things are getting created just with a few clicks of a button. So a VPC will be created for us, and then four subnets will also be created, 3 route tables, and then a couple of internet gateways. Now this is really convenient, but since we are in a learning phase and we want to explore everything individually, I'm going to click on VPC only. So this gives me a few options that I want to select from. So the first thing it is asking, what should be the name of our VPC? So if I can come back to the spreadsheet, you see here we already specified the name of our VPC. So I'm going to just copy that. I'm going to go back to the management console. I'm going to paste it over here. So that is done. The next thing we have is the IPv4 CIDR block. So this is essentially the range of IP addresses for our VPC. So I'm gonna say 10.0.0.0/16. Now let me give you a quick tip. Never ever use an IP range over here that overlaps with your existing network. So let's say that if you have an existing network that is implemented on premises, you should actually check that if the IP range that you're specifying, it is not overlapping with your existing network on-prem. Or similarly, if you have, let's say you have a multi-cloud architecture and you're using different cloud providers and you have the network implemented on some other cloud provider, and you want to make sure that this IP range, it is not overlapping with the one that is there in your other cloud provider. Because if this happens, there are going to be problems for you, and you won't be able to properly communicate between different services. So that is not going to be ideal. So we want to ensure that we have an IP range that is not overlapping over here. So with that, we don't have anything else to add over here. So we're just going to click on create VPC. And with that, our VPC should be created. Yeah, it is done. So our VPC is created. Now the next thing that we want to do is that we want to create our subnets. So I'm going to click on the subnets from this left-hand menu. I'm going to click subnets, and we have some default subnets already created. But what we're going to do is that we're going to create a new subnet from over here. So in order to create a subnet, you have to specify some things. First of all, you want to select the VPC that you will be creating your subnet in. So I'm going to click on this drop down, and we have a couple of options. One is the default VPC, and the other one is the VPC that we have just created. So we want to use this one, the VPC production one. And when you select that, there are a few more details that we want to provide. So we want to provide the subnet name, and from the spreadsheet, I can simply copy that. So let me do that. So over here we have the name of the subnet added, and the next thing that we have is the availability zone. So we want to select the US East 1A, and if you don't see this availability zone over here, then that means you are probably in the wrong region. So you want to ensure that you are in the Northern Virginia region from here. So I'll select this US East 1A, and then we want to specify the IPv4 CIDR block, and we want to ensure that this CIDR block, this is a subset of what we have in the VPC. So I'll come here, I'll type in 10.0.0.0/24. So this is now a subset of this CIDR block, that is 10.0.0.0/16. So that is done. And now we want to add a new subnet. Let me quickly open the architecture diagram so you are aware of what we're doing. We have created the public subnet. So here we are. We have already created the public subnet. We have not yet created. We have just provided the details for that. And now we need a private subnet as well. But there is a thing that is not really specified in this architecture diagram, is that we don't have to create one private subnet. We actually have to create two private subnets. The reason for that is that we want to store our database in this private subnet, and it is a requirement of RDS that we actually have it in multiple different availability zones. So we are going to create two private subnets in different availability zones. So I'm going to go back to AWS, and I'm going to click on this add new subnet button, and it will let me add another one. So what I'm going to do is that, again, I'm going to copy the name from the spreadsheet. So I'll come here and I'll copy it. I'll paste it over here. Now, since this is the first private subnet, I'm going to select US East 1A for this one. And the IPv4 CIDR range, again, this is going to be a subset of what we have. So I'll go 10.0.1.0/24. So this is, again, a subset of what we have in the VPC, the range that we have defined in the VPC, and we have added the name. So now it's time for the second private subnet, and this will be in a different availability zone. So I'm going to say 2 over here, since this is our second one. So for the availability zone, I'm going to select the 1B, and then similarly, I'm going to give it a range 10.0.2.0/24. So again, we have specified in the subnet, And then I can simply click on the create subnet button, and with that our subnets are creating. So if you see here, we have the subnet successfully created. Next step, we're going to create our internet gateway. I'm going to come here, I'm going to click on internet gateways, and then I'm going to click on create internet gateway. So once I do that, the create internet gateway screen pops up, and we're going to provide the name. I'm going to say IGW-mod 3. So with that, we have created the gateway. But if you see over here, it says the state of this gateway, it is detached. And up top, there is a message as well. The following internet gateway was created, and you can now attach to a VPC to enable the VPC to communicate with the internet. Yes, that is what we want. And there is a button as well that says attach to a VPC. But in case you don't have this message, or for some reason you have actually clicked on the close button over here, so don't worry, you can attach the internet gateway to a VPC using this actions button. So if you click on this one, there is a message that says attach to VPC. I'm going to click on that, and it is going to ask me that which VPC do you want to connect it to, and it is going to show me the available VPCs. So I'm going to click on this list, and it says that there is one VPC, that is the one that we're looking for, the VPC-production-1. I'm going to select that. I'm going to say attach internet gateway, and with that the state has changed to attached. The next thing that we want to do is that we want to update our route tables. So I'm going to click route tables from this left hand menu, and if you see over here, we have a route table already created and selected. And right now I believe we should be having multiple route tables, since there is a default VPC as well. And up top there is a filter. For some reason you can just simply click on clear filters. I'm going to do that. So if you see, we have multiple route tables, and what we're going to do is that we're going to be working with this one that says the VPC-production-1. The above one, this is the default VPC, and we're more interested in this in route table. So I'm going to select this one, and over here we have the routes tab. I'm going to click on that, and if you see, we have just one route over here at the moment that actually is from the local, and the destination is also local. So you can say that this is the local communication. This route is for that purpose. And what we're going to do is that we're going to create a new route. So how do you do that? You can click on edit routes button, and it will take you to the screen where you can modify the existing route, and you can also add a new route. So I'm going to click add route, and over here I'm going to specify 0.0.0/0. So basically what we're saying is that we want anything to be the destination. So any request that is coming in, we want to allow that, any location, and then the target, that will be the internet gateway. So I'm going to click that, and then it is going to ask me that which internet gateway do you want it to be routed to, and then we're going to select the one that we have created. So what we're actually doing is that we're allowing traffic from the internet, from anywhere in the internet, to our internet gateway, and then eventually to the EC2 instance that we'll be creating. And also similarly, this will also help us in for our EC2 instance to communicate with the internet, to if you want to install any packages or any scripts you want to run. So this will help us with that. So with that, I'm going to click save changes, and our route table has been updated. So the next thing that we want to do is that we want to create our EC2 instance. And for that, I'm going to come here in the search bar, and I'm going to type EC2. And this will take us to the EC2 dashboard. So here we are, and you can see a lot of different things over here. But what we're interested in is this launch instance button. So I'll click on that. And over here, we can actually provide the details for this new instance. And first of all, we're going to be providing the name. So if you remember, we actually came up with a naming convention, and we agreed a name in the planning phase. So I'm going to come to the spreadsheet, and then I'm going to copy the name from here. So I'm going to select this, and then I'm going to copy. I'm going to come back, and I will paste it over here. So that is done. We have the name. And the next thing that we want to do is that we want to ensure that we are using the Ubuntu image for our EC2 instance. So I'll click on Ubuntu, and then we're gonna select that which Amazon machine image we want to use. So we have over here the 24.04 LTS version that is free tier eligible, and we want to ensure that we are using one that is actually free tier eligible. So if you see here, we have another one that is 22.04 LTS. So this is also usable. I'll click on that. We can use that. So I'll click confirm changes, and then I'll scroll down a bit, and over here we have the instance type. So right now the one that is selected, that is the T2 micro, and again this is free tier eligible, so we want to ensure that we are using one that is that will not incur us any cost at this moment, since we are in a learning phase and we're not really working on a production project. And also another thing was that we actually agreed upon the instance type as well during the planning phase. So let me come to the spreadsheet, and if you see here, we actually decided that we're gonna be using the T2 micro instance type over here. So that is selected, T2 micro. We have other options as well. We have T2 nano, T2 small, T2 medium, but if you see, T2 micro is the one that is actually falling in the free tier. So we're gonna use that, and then what we're going to do is that we're going to create a key pair. So this will help us connect to our EC2 instance over SSH. So I'll come here and I'll click on the create a new key pair. I'll give it some name. So let's say that I'll say connection SSH, and I'll create the key pair. I'll download it on my machine, and it is done. So I'll come down here. The next thing is we have the settings, network settings menu. Now this is very important because currently things are not in an editable state and we want to modify things, because right now I can see that the VPC that is selected, this is not the one that we have created. This is probably the default one. So we want to change all of that. So how do you do that? You can just simply click on this edit button, and this will allow you to edit all these settings. So the VPC, and we were right, the default VPC is currently selected. So what we want to do is that we want to change that to the one that we have created. So I'll do that. The next thing is that we have the subnet, and the subnet is, I believe, correctly configured over here. We can see the VPC dash production dash 1, and the public one is selected. Why we want to do use the public subnet over here? Because we want to ensure that users are actually able to communicate with our EC2 instance, and since we're going to be hosting the server over here, so we want to ensure that we are able to process all those requests and people are able to communicate. So for that reason, we are currently going to leave this in the public subnet. But when you're working on a real world project, you want to ensure that you understand the use case correctly, whether the public subnet is suitable for you. If not, then please avoid that and use a private subnet. But if it is needed, then you can use the public subnet as well. So next up, we have the auto assign public IP. I'm gonna enable that. And up next, we have the security group settings, or you can call it the firewall. So what happens over here is that with security groups, we can actually configure some rules that we want to allow traffic from what sources we can specify over here, and this way we can actually control the traffic that is coming in and to our EC2 instance. So for that, what we're going to do is that we're going to create a new security group, and I'll rename it. I'll say app01-SG, and this name, actually I've already added that in the technical documentation as well. So if you want to follow along and use this naming convention, please feel free to refer to the technical documentation, and you can get these from there. Next, I'm going to copy this name over here, and I'll paste it in the description as well. So if I come here to this inbound security group rules, so this is where actually all the magic is happening for our firewall settings, or we can say the security group rules are specified over here. So we have one rule already existing, if you see over here. So what is happening is that we have the type as SSH. So it means that this rule is for SSH access, and this will typically be used for securely logging into remote systems. So we are actually specifying some way to do that. And then we have the TCP protocol again, which is common for SSH. Then we have the 22 port that is specified, which is a standard port for SSH connections. Then we are specifying that the source type is anywhere, which means that we are actually currently allowing traffic from anywhere. And again, a similar thing that is specified over here is that the source is 0.0.0.0/0, which means that we are allowing access from any IP address in the world. So what we're doing, actually, we are allowing people to connect to our EC2 instance over SSH, and we're not specifying that we want just these few people to be able to access. We are actually saying that we want anyone to be able to access our EC2 instance via SSH. And if you see here, we already have a warning message that the rules with the source of this allow all IP addresses to access your instance, and we recommend setting security group rules to allow access from known IP addresses only. So now what you want to do is that you want to ensure that whenever you're working on a real world project, you want to ensure that you are specifying the IP addresses that should be able to access your EC2 instance. Everyone should not be able to access your EC2 instances over SSH. So you want to ensure that you're only providing maybe your IT team's IP addresses, or some you can say leadership IP addresses, something like that. You want to ensure that you are specifying the IP addresses, and you don't want to follow these this anywhere source type. But since this is just a tutorial, so I'm going to proceed with that. And what we're going to do is that we're going to add a new security group rule. So what do we want to achieve here is that we want to ensure that our EC2 instance, it is able to actually communicate to the internet, and we are able to access the internet. And if you want to download any new package or anything like that, so we are able to do that. Over here we have the type, and I'm going to leave that as custom TCP, and the protocol is again going to be TCP. The port range, we're going to specify 8080, and the source type, this is not going to be custom. We're going to select anywhere. So what we're actually specifying here is that we want to allow people from anywhere in the world to be able to communicate with our EC2 instance. And similarly, this will also help us with our EC2 instance to be able to connect to the internet, so we can download our packages and everything. So this is what we're needing over here. And again, it says that rules with the anywhere sort of the IP address, it allows everyone to be able to access. And but we are okay with that, since this is just the communication. So with that, I'm going to come here, and what we're going to say is that this is fine, not going to update that 8 GB of storage. So we're okay with that. And with that, I'm going to click on the launch instance button. But before that, what we're going to do is that we're going to quickly review everything, that if everything is fine. So our storage is fine, our security group rule is fine, the naming convention is fine, and then the subnet and VPC is correct. We have the key pair, we have the instance type, we have the AMI over here as well, and the name for the EC2 instance. So what I'm going to do is that I'm going to click on this launch instance button. So it is going to take some time to create the EC2 instance, and in the meanwhile, it is done. Actually, we were able to launch the EC2 instance. I'm going to go to instances, and we'll see that if it is up and running. So over here, the instance state is in pending, so it will take some time to bring it up and running. So in the meanwhile, what we'll do is that we'll go to RDS and we'll create our database. So what I'm going to do, I'm going to type in RDS over here, and this will take us to the managed relational database service. I'm going to click on that. Over here, you want to ensure that you don't have any database instance currently running. And what I'm going to do is that I'm going to click on the create database button. So I'll click that. And over here, we have different options. We have the standard create option, then we have the easy create option. So I'll go with the standard create options, so that we are able to set all the configurations options, and including the ones for availability, security, backup, and maintenance. So we want to go with this one. This way we have more control of what we are doing. So I'll go with that. And then we want to select the MySQL database. I'll do that. And over here we have the MySQL engine version. So we have multiple options. We have the MySQL 5.7, then we have the MySQL 8.0.3 as well. So I'll come to the spreadsheet and see which version we are currently running on-prem. So currently on-prem we are running the 5.7 version, and ideally what we want to do is that we want to have the 5.7 version over here as well. But what happens is that if you see over here that the MySQL engine version earlier than 8.0.17 don't support the newest M6G instance classes. So what happens is that for that reason I would actually have to enable this RDS extended support, but this is a paid offering, so I don't want that to happen. So I'll simply uncheck this button and I'll go to a newer version of database. So I'll select 8.0.35. So this way we actually don't have to enable this RDS extended support. But again, when you're working on a real world project, you don't really want to upgrade your engine version, as this could cause problems. Since right now we're in a learning phase, so I don't want any extra additional costs to be incurred. So that is why we're going to be upgrading to the 8.0.35 version. So down below we have different templates. We have the production one, we have the dev test one, and then we have the free tier version. And again, since we are in the learning phase, we don't want to be charged anything. So I'm going to select the free tier version. And when I select that, you saw that we had different options that were enabled earlier and now they're disabled. So our availability and durability options are gone, and we can't really modify them in the free tier version. And if I come down below, so what is happening here is that we actually want to specify the database name over here. So I'll come back to the spreadsheet and I'm going to copy this from here. I'll do a Control-C, Control-V, that is done. And down below we have the passwords, the credentials. So currently the username is admin. I'm going to leave that as it is. But again, it is a good practice that you want to update this username to a more, you can say, relevant one to your use case. So I'm going to leave that to admin right now. And the password is going to be admin123456. So that is fine currently. Admin123456. So that is done. I'm going to scroll down below, and then over here we have the instance class. If I come to the spreadsheet, we decided that we're going to go with the T2 micro one, as this was the one that was more suitable to what we had on prem. We just need 1 GB of RAM, 1 vCPU, and then 2 GB of storage. So what we also decide that we are open to upgrades, that if we are able to get a similar version on AWS, that is fine. Or if we get a better version than this, that is also welcome. So I'm going to come here and I'm going to open this up. So we have multiple options over here, but right now I can only see 4 options that are available to us in the free tier. So we have the T3 micro and we have the T4G micro, and both of them are actually, you can say, they're very much same. They have 2 vCPU, 1 GB of RAM, and this is what is happening over here as well. We have 2 vCPUs and then we have 1 GB of RAM. So I'll select T3 micro. That is fine. We don't have T2 micro over here, so that is fine. We went with T3 micro, and what we got was that we got 2 vCPUs, we got 1 GB of RAM, and the storage fees that we have not yet seen, but I think currently the T3 micro, that is a big upgrade on what we had on prem, so that is a welcome change. So what I'll do is that I'll update this spreadsheet to point to T3 micro, since that is what we have went with. So I'll say T3 micro over here, and I'll scroll down a bit, and there we are with the storage options. So the minimum storage value is 20 GB, and that is more than enough. We just had 2 GB of storage on prem, so that is a huge upgrade again. 20 GB, that is fine. And I'm gonna scroll down below. So over here we have the connectivity settings. We don't want to connect to an EC2 compute resource, so I'll leave that as it is. And over here we have the virtual private cloud, the VPC, and currently the default VPC is selected. And again, once the database is created, we can't really change the VPC. So it is important that you select the VPC that you have created. So I'll select the VPC production 1. That is the VPC that we are working with. And down below, I'll select the create new DB subnet group, and that is fine. Over here we have the public access options. So either we want our RDS to be assigned a public IP so that people can outside of our VPC they can connect to our database. So we don't want that, and that is the reason that if I can come to this the architecture diagram, that is the reason that we went with the RDS to be placed in a private subnet, so that people outside the VPC they are not able to access that. We can only have communication from within the VPC via our EC2 instance. That is going to be our web server. So that is I'm going to go back here and I'm going to select no. We don't want our RDS to be assigned a public IP address. Only Amazon EC2 instances and other resources inside the VPC can connect to our database. So that is a security best practice, that you don't allow public access to your database. That is fine. And over here we have the security group settings, the firewall settings. So I'm gonna create new security group. I'm gonna call it app02-sg. So that is the name, and the availability zone for this is going to be the 1A availability zone. And again, everything that we are doing, we are actually following the spreadsheet, and if something is better, then we do that, we update that. Otherwise we follow the spreadsheet. And over here you can find the availability zone as AZ1, and that is the US East 1A. So we have selected that, and I'm going to leave the proxy and the certificate settings as it is, the default ones. And I'll scroll below the database authentication. We're going to use the password for authentication. We don't want enhanced monitoring. That is fine. And if you see over here, we have the estimated monthly cost, and then again we have the estimated monthly cost repeated twice. So what is happening is that currently we are in the free tier, and free tier is available to us for 12 months. And that in that 12 months what is allowed to us is that we are allowed 750 hours of RDS in a single availability zone, and we'll be having the T2 micro, either T3 micro or the T4G micro instance. And if you remember, we only had these two options. We had the T3 micro and T4G micro. So we went with the T3 micro, that is in the free tier, and 20 gigabytes of general purpose storage, that is what we have, and then 20 gigabytes for automated backup storage. So that is fine. We are okay. And once we are done with the 12 months of free tier, then we are going to be charged this much amount. We are going to be charged with $14.71 every month. So that is fine. We are not going to be going beyond the 12 months for our learning. So that is fine. I'm going to click on create database. It will also take some time to create the database. So as soon as we created the database, we got some suggested add-ons. So I'm gonna close. We don't want currently these add-ons. They are beyond the scope of this project. So I can say close. And if you see, the database is currently creating, and the database identifier is the one that we have selected. We are using the T3 micro as the instance size. Just to quickly recap on what we have done in this video. So we have created a VPC, and then we created a few subnets, and we also created an internet gateway. Then we went to add some routes rules to our route table, and then we created an EC2 instance and a database, and then we also specified some security group rules. So let's look at the migration process and see where we are standing. So currently we're in the running phase, and we are done with most of the deployment pieces. The only thing that is currently pending is the preparation, that we need to install some softwares and install some libraries to the EC2 instance and all that stuff. So we'll do that in the next video, and with that we'll be ready for the go live phase, and then we'll complete the migration process. We are actually going to prepare our EC2 instance to install or set up some libraries and some software that we need to connect to our database and to be ensured that our application is up and running. So let's get into it. So let me quickly pull up the Excel sheet that has the planning details. So if you see here, we have already created the EC2 instance. We already have set up the RDS service. And now what's left here is that we just need to ensure that these prerequisites are actually taken care of, and our EC2 instance is up and running to be able to connect to the RDS database, and we are able to ensure that the migration is successful. So there are a few things that we want to ensure that our EC2 instance have. So first of all, it has to be a Ubuntu operating system. That is already done. In the last video, we created the EC2 instance with the Ubuntu operating system. And now we actually have to install some packages, some libraries, some software. So for example, we have to install Python. We also have to install the Flask library. So all of this stuff we need to ensure that our EC2 instance has. So what I'm going to go do is that I'm going to go to Amazon Management Console, the AWS Management Console, and over here I'm going to type in Cloud9. So Cloud9 is actually, you can say it is a cloud IDE that we can use to write code. And we can use this to connect to our EC2 instance via SSH. So it has a terminal, so you can use that. You can also use some other terminal. So you can use Git Bash, you can use Visual Studio Code for that purpose. But since we are going through the AWS services, so Cloud9 is a service that we can use. So I'm going to click on Create Environment. And what I'm going to do is that I'm going to provide the name to this environment. The name is going to be AWS Bootcamp, and the description is optional. We can skip that. This is going to be a new EC2 instance, and again, this is going to be a T2 micro, and this is free tier eligible. Again, we don't want to incur any charges as of now. So how long Cloud9 can be inactive before auto hibernating. So this is something that we can actually set up. So since 30 minutes is fine. So if we don't use our Cloud9 instance for more than 30 minutes, it goes automatically into hibernation state, and that is fine. So we can use AWS System Manager, that is fine. And I think everything looks good. We can go with the default settings. So I'll click on Create. And it might take some time to actually get this instance up and running, and let's see that if it is we are able to access it. So I'll click on Open. Yeah, so it says that this can take a few minutes. So let's give it a few minutes, and let's come back when it's ready. All right, so our AWS Cloud9 development environment is ready, and if you can see here, we have different options. We can configure the appearance and all that stuff, and also we can create a new file, we can upload files, and we can clone our GitHub repositories. So I believe this gives you the idea that the Cloud9, it is an IDE, and an IDE stands for the integrated development environment, where you can do development, you can write code and all that stuff. So but the purpose that we're going to use Cloud9 for is it also has a terminal. If I can drag it up, so if you see here, we have a terminal, and we're going to use this terminal to connect to our EC2 instance. And in order to connect to the EC2 instance, if you remember, when we were creating the EC2 instance, we created a key pair, and that security key pair, actually, it is very important, and it is needed in order to connect to the EC2 instance. And if you somehow lose that, there is no way that you can go back and create that again. You're gonna have to just come up with a new EC2 instance. So what I did was that I actually saved that SSH key, and I'm gonna upload that to this Cloud9 development environment. So I'm gonna click on Upload Files. I'll click Select Files, and then I'll click on connection-SSH. So I'll upload that over here. That is done. I'll close this. Let me drag this up. Okay, and also let me see if I can zoom in a bit. Okay, so that looks better now. And what we're going to do is that we're going to connect to our EC2 instance. And how do we do that? We actually need the public IP address of our EC2 instance. So I'm going to go there. I'm going to go and copy the IP address, and I'm going to come back here. So the command is something like this. So I'll type SSH, and then we'll type in Ubuntu @ and I'm going to paste the IP address, and then I'm going to pass in the I flag, and then I'm going to actually provide the name of the key pair file that we have. So it is connection-ssh.pem, and I'll press enter, and I'll say yes. Okay, so now if you see here, it actually gives us an unprotected private key file warning, and it has actually denied us to connect to the EC2 instance. And there is a command that we can use to actually work around this problem. So if you face this issue, just type in chmod and then type in 400 and the name of your connection file. So I'll type in ssh.pem and I'll press enter. So it returns nothing. It says nothing. And you can simply try to connect to your EC2 instance once again. I'll run the same command. And there we go. We are now connected to the EC2 instance. So I'll press clear. So now we have to actually install a lot of packages and libraries. But the thing is that whenever we run an install command or something like that, so what happens is that there are going to be a lot of pop-ups to confirmation and all that stuff. So now, since we want to speed things up a bit, we have everything documented, and we want to try to do it in a way that we are not interrupted by all of those pop-ups. So if I can run this command, so if you see here, there is an I written over here. And what this I suggests is that currently we are in the interactive mode. So whenever we are trying to run or install anything, any library, any package, it is actually going to give us pop-ups, and this is going to run in an interactive manner. Now, what we want to do is that we want to ensure that we change this I into an A. And for that, I have some commands over here. And all of these commands, they are actually available in the technical documentation. You can follow along using that. So you can copy this from there. And I'm gonna press enter. And if I run the same command now once again, so if you see here, we have the A now. So now we are in the automatic mode. So whenever we install any package or library or any dependency, so we shouldn't be getting those alerts or pop-ups or something like that. So we should be good and we won't be interrupted. So with that out of the way, let's start running our first command. Let me type in the sudo apt update command. So it will take a few seconds or moments, I should say, and it will be fairly quick to complete. So please bear with it if it takes a few moments. In the meanwhile, let me copy the next command from the technical documentation. So that is done. And let's do the next command. Another best practice whenever you're working with the terminal is that you should occasionally type in the clear command so that the screen becomes clear and it is easier to read and understand things. So I'll do that here, clear. And if you see, everything looks clean, and clear doesn't mean that you're actually losing everything. So if you can scroll things up, so you're gonna get back to everything again. So that is a very handy command, and you should use that regularly. So now I'm gonna come to the next command. Again, it will take a few moments to install, so allow it the time, and we're done. I'll type in clear once again, and I'll paste the next command. I'll type in clear, paste the next command. Again, I'll type in clear, paste the next command. Again, we're going to type in clear, and I'm going to paste the next command. The next one. All of these commands are available on the technical documentation in a sequence, so you can follow along using that. That will be really helpful. And the next command, I'll type in clear. Okay. So if you see, we got a warning that says that currently Flask is installed in this location, and this location is currently not on path. So in order to solve this problem, we're gonna run this command. Again, this is available in the technical documentation. We are just adding that location to the path, and then I'm gonna install the WT forms. It is done. Now we need to install the next config, the package config. Now we're installing the Flask MySQL database library. So again, it will take a few moments to get all of these installations in place. And if you see, when we're working through this process, the idea that we already have everything documented, and we have already identified all the dependencies, and we have already written the you can say equivalent statements or commands to actually install those dependencies, that comes in really handy, because when you're working on a cloud migration project, you need to have everything documented. So when you're working on the actual stuff, you don't really get worried, and you're not confused, and you don't miss out on anything. So documenting everything is really important. And with that, almost all of the libraries are done. Let me type in clear. We just have a couple of them left. So parslib is the one. And now the last thing that we want to install is that we want to install the MySQL client. And for that, we have the command over here. I'm gonna type in that and press enter. And there you go. All of the dependencies are done, and I'll type in clear. And if you face any problems when you're following along, please feel free to refer to the technical documentation that is recommended. We're actually going to make the connection between the EC2 instance and the RDS database, and we're also gonna be loading some data, and then we're gonna be testing things out. So let's get into it. So what I'm gonna do is that I'm gonna search security groups. And these security groups, the thing that I want to do is that I want to create a new security group. And the reason for that is that I want to ensure that there is a rule added that allows my SQL database to be able to communicate it from the internet. And again, this is something that when you're working in a production environment, you don't want that to happen from anywhere in the internet. You want to have some specific IP addresses that should be able to access your database. But since this is a demo project, we're just here to learn things, I'm gonna allow it to be accessed from anywhere in the internet. So I'm gonna click on create security group, and I'm gonna give it a name. I have the name written in the technical documentation. I'm gonna copy that from there. So I'll call it EC2 to RDS dash security group, and the description we can leave as it is. And I'm gonna select over VPC, and then there is gonna be one rule that we want to add, and that is gonna be an inbound rule. I'll click on add rule. I'll search in Aurora. So this is the type that we want to select, and again, this is gonna be anywhere. So this is the rule that we want to add, and I'll click on create security group. Okay, so a security group description is needed. Okay, so security group to connect EC2 to RDS. So that looks good. I'll click on create security group, and with that, the security group is created. Now what we want to do is that we want to apply this to our RDS instance, and I'm gonna go to RDS, and I'll go to database instances. So over here we have the database that we created. I'll select it. I'll click on modify. And over here, we want to actually specify that the security group that we have created. So we want to specify that. So if you remember, we selected the default security group when we were creating this database. So I'm going to cross that, and I'm going to select the one that we have just created. So that is done. And now I'm going to click on continue. And it is going to give us a couple of options. We can apply during the next scheduled maintenance window, or we can apply immediately. I'm going to click on apply immediately. and I'll click on modify database instance. And with that is done. So now what we want to do is that we want to actually validate the results, that if we are able to now connect to the database. So for that, what I'm going to do is that I'm going to again go to Cloud9, and we're going to try to connect to the RDS database from our EC2 instance. So I'll click on Cloud IDE. All right, so here we are connected to our Cloud9 environment, and the very first thing that we want to do is that we want to connect to our EC2 instance, and the process for that is very similar to what we did in the last video. I'm going to click on SSH. I'm going to type in SSH, apologies for that, and we want to type in Ubuntu @ and we want to provide the IP address, the public IP address. I have that copied already, so I'll paste that. I'll type in the -1 flag. And we also want to pass in the name of the key pair file that we have. So that is connection.ssh.pem, and I'll press enter. And there we go. We are connected to the database, and I'll type it. Sorry, not the database. We are connected to the EC2 instance, and I'll type in clear. So that makes it neat and clean. So now what we want to do is that we want to install or run the application server that we have on this EC2 instance, and then we also want to connect that server to the RDS database service. But the thing is that currently the database, it doesn't have any data in it. It is a newly created database, so we want to also dump some data. So let me run a few commands to actually download the file that we have, the application server that we have, and also let's download the some dummy data for our database. So I'll paste the command, and now what we're doing here is that we are actually downloading the wiki app that is going to be the server, the application server, and it is going to communicate with the database. So I'll press enter, and we have downloaded that. And the next thing that we want to do is that we want to download the dummy data, the dump SQL dump that we have, and we will actually import this dump in the MySQL database that we have. So that is also done. I'll type in clear. And the next thing that we want to do is that we want to connect to our RDS database, that is the MySQL database that is hosted on RDS, and the command for that is MySQL, and then you provide the H flag, and now we need to provide the endpoint to our MySQL database. And how can we get that? So we have to go to the AWS Management Console, and I'll open RDS. And in RDS, we'll click on database instances, and then click on DB identifier. And over here under connectivity and security, you can actually find the endpoint. So I'm going to copy that. And what we want to do is that we want to come back to the Cloud9 environment, and then paste the endpoint that we've copied. And now we want to provide the -p flag that is basically for the port, and we want to provide the port as 3306, and then the -u flag for the username, which is admin, and the -p flag, which is for password. And we don't specify the password. We let it ask us the password. So if I press enter, it will ask us the password, and the password is admin123456. So that is done. Now we are connected to the MySQL database, and now what we want to do is that we want to run some queries over here. So if I can run this query, this show database query, so what it does is that it returns us all the databases that are currently present in this MySQL database. And what we want to do is that we want to create a new database so that we can use that database to hold over data, and we're going to be calling this database as WikiDB. So I'll create that. So that is done, and now we want to execute the query to again list all the databases. So I'll again do a show databases, and if you see, WikiDB is now created. So that is done, and now we want to actually use this database. So if you see, we are going to use execute this query that says that use WikiDB, and what it does is that it sets the current database as WikiDB. So whenever we make any changes or we query any table or anything, so we'll be using the WikiDB. And I'll press enter. So database is changed, and now I'm gonna run the query that says show tables. So what it does is that it returns us all the table, and if you can see, we currently don't have anything, so it returns empty set. And now let's actually include all the data that we got from the dump to this database. So the query for that is source, and then we can provide the file name. So it was dump-en.sql. So if I press enter, so if you see, a lot of things happened, we got a lot of data. And now if I again run the show tables query, so if you see, we have a couple of tables created. We have the articles table, we have the users table, and now what we can do is that we can actually run a query to select some data from the articles table. So let's do a select static from articles. And if you see here, we have got some data back. So this is the you can say the dummy data. And now let's move ahead with this process. So all of this looks good till now. And let's create a new user, and the query for that is available in the technical documentation, so you can copy it from there. So I'll press enter. So the user is created, and now let's grant some privileges to this user. So I'll press enter, and that is again done. Now let's quickly flush the privileges, and we are done. So let's exit. So that is looking good. I'll type in clear. Okay, so now the SQL database seems ready. It has data in it and all that stuff. So now what we want to do is that we want to actually make sure that our application server that is up and running, and we are able to connect to the database using our application server. So if you remember, we downloaded a couple of files. One was the dump, and the other was the technical application server, should I say. So now if I can do a quick ls, and if you see, we have a couple of files available. The dump and the wiki app is the zip file, and now we want to unzip this. So for that, the command is unzip, and we want to provide the name. So I'll say wiki app -en dot zip. So that is done. And now we want to actually do again a quick ls, and if you see, we have a folder that is called as wiki app. So I'll do a quick cd, and we'll go into this folder. So now here we are in the wiki app folder, and if I again do a quick ls, so we have a few files over here, and the main file that we have is this wiki.py file. This is the Python file that has all the code, and what we want to do is that we want to actually open and edit this file, and we want to ensure that our details are available in this file. So let's say that our endpoint is available and all that stuff is available over here. So we can to edit this file, what we want to do is that we want to type in the vi, and then we want to use this file name. So that is wiki.py, and I'll press enter. So if you see here, we have a lot of you can say stuff in this file, and what we can do is that we can press insert to edit this file, and I'll do that. I'll type in the insert key, and now this is in the editable mode. And now what we want to do is that again we want to update some fields over here. So if you see, we have the app config, and there is a host and the user, and now we want to actually update the host. This is not this is not the host, the db server 01. So we again have to go back to the RDS service, and we have to actually replace this. Let me quickly remove this, and if I can go here, I can copy this again and come back, and let's do a control V. So that looks good. And if you see here, the user is wiki, that looks good, and the MySQL password is wiki123456. And if you remember, when we created, the password was admin123456. So we want to change that as well. So let me come here. I'll type in admin, and everything looks good now. So what we want to do is that we want to press the escape key, and with that, this we should be good to we are now out of the insert, or we can say edit mode, and now we want to save and exit. So for that, the command is that we type in the colon, and we type in X, and that should actually help us in saving and exiting. So that's look good. Now our database seems ready, our application server also seems ready. So what we want to do is that we actually want to run this Python file that we have. So the command is something like this: python 3 wiki.py. Now this command should help us in executing this Python file. And if I type insert enter, so if you see, it seems to be running, and it is also giving us the IP address. This is running on this IP address. But let's go to the EC2 instance and let's copy the IP address from there. So if I can go back to Amazon Management Console, so let's go to EC2. Let's click on instances, and if I can click on this, I can copy the public IP address. I can open a new incognito window. Let's paste it over there, and let's type in 8080 in the URL, so we are able to actually see that if it is up and running. Voila. So if you see here, we have the application up and running, and we can see that there is a home page that is available. So that means that our application server is running correctly. And now let's log into this application to see that if the database is also connected and all that stuff is happening. So let's click on login, and I'll provide the username as admin and the password is also admin. So I'll press enter. There you go. We can see that all the data that was available in the articles table, it is now present over here. And now what we can do is that as part of this, you can say, validation process, we can create a new article or we can quickly edit one. So let me quickly edit this article. And if I can say that test, and I can click on the send button. So now this should update. Okay, there we go. We can see that the application is working correctly. The data is actually also working correctly. So everything looks good. And with that, our migration process has completed. Our web server is now up and running, and we are connected with our RDS database. That is also everything is hosted on AWS. So we are completely disconnected from, you can say, in a real world scenario, we are now completely disconnected from the on-prem environment, and we are currently fully running on AWS. And if you are working on a real world project, so what you would do is that you would now actually turn off your on-prem applications and everything, and you can simply bring in real data to this database, and you should be completely on AWS. And the next step is actually the support and the monitoring. So you and your team, you'll be actually providing the support, and you'll be monitoring this application and the web server, and you'll be seeing that if everything is working up and if everything is up and running, and if everything is working correctly. So with that, you should be good with this migration process. And once again, congratulations, bootcamper, you have successfully completed another hands-on project, and I'm really happy and really excited that we have made it so far. And now what we want to do is that as part of the project evidence, I want you to create a new article over here. So if you're following along, I want you to create a new article and add in your name. And also another thing that you want to do is that you want to ensure that the screenshot is available in the URL is also visible in the screenshot that you attach. So with that, everything looks good. And the last thing that I would also like to remind is that kindly do not forget to delete the, or you can say terminate the EC2 instance that you have running, and also do not forget to delete the RDS database. And we don't want to incur any charges, so it is better that we terminate and remove everything that we have from our AWS account. So I'll see you in the next video, and till then, take care. Bye bye.
And this was just one of over 40 hands-on projects our students build inside the Cloud Bootcamp. Here you truly learn by doing, solving real-world enterprise challenges, and building a portfolio that actually sets you apart in the tech industry. On November 24th at 8 p.m. Eastern Time, you'll have the chance to get lifetime access to all our bootcamps, including cloud, DevOps, artificial intelligence, and special bonuses revealed only live. If you haven't signed up yet, click the link in the description or scan the QR code on the screen to secure your spot now. This is the last time ever we will offer lifetime access to our bootcamps. If you enjoyed this video, drop a like, subscribe to the channel, and turn on notifications so you don't miss the next projects we'll be showing here. And of course, I'll see you live on November 24th.